And we're back. And we're back. Whoops. We're back with example 2. There we go. There's the microphone. We're back with example 2. Example 2, we are still looking at solving log equations, but this time we're using something called the log property of equality. So let's talk a little bit about what that is. The log property of equality. Now, we've had properties of equality before with different functions. We had a property of equality for radicals, and we learned that we could take the square root of both sides of the equation at the same time. We had a property of equality for exponentials, and we learned that if the bases are the same on either side of the equation, if we had b to the x equals b to the y, then x equals y. So we learned those and used those properties, and the log property of equality is very similar to that. It looks like this. So if you have, I kind of want to change my pen color, but I don't see my palette to change my pens, so I won't worry about it. That's okay. So if you have this, the log base b of x equals the log base b of y if and only if, you ready, x equals y. So this one is very similar to the property of equality for exponentials, because remember there we had b to the x equals b to the y, so x equals y. Well, now what? We've logified that, right? So we said log base b of x equals log base b of y if x equals y. This is what we're going to use in the second set of examples. So let's get on with it. Here we go. So we're going to do example 3, because in our first one we had 2 examples pretty much of the same thing. So maybe we should say this is example 2. It's the third problem we're doing, but I guess it's really example 2. All right, so we're going to start out like this. Log base 3 of x squared minus 15 is equal to log base 3 of 2x. All right. Now you notice what? I've got logs on both sides this time, don't I? And I notice that both of them are base 3. That's good. They would have to be in the same base to use this property. See, log base b. This isn't log base b and log base c. They're both the same number here. Well, that's exactly what I have. So this follows the pattern in the equality property. So what does that mean I can do? If I have 2 logs, they're both in the same base and they are equal to each other. There's not other stuff going on. All I have is log of this equals log of that in the same base. Don't have other stuff happening. Just 2 logs equal to each other. If that is the case and they're in the same base, this property says I can set the arguments equal to each other. And so that's what we're going to do. Let's set the arguments equal to each other. All right, so this is the argument of the first log on the left side, and this is the argument of the second log on the right side. So now I'm going to say what? X squared minus 15 equals 2x. And all of a sudden, what the heck? The logs went away. And why did they? Well, we used the property, and now we look at it like, wait, it's not even log or exponential anymore. Now it's quadratic. Yippee. Why? Because quadratic we've done, and it's really algebra 1. So how do we solve a quadratic? We got to set it equal to 0 and see if we can factor. So just kind of make a note to yourself, oh, yay. I mean, it could be linear, but this one is quadratic. And how do we solve quadratic? we got to set it equal to 0, which means what? We got to bring all the terms on one side. We have 0 on the other side. You can move the terms to either side you want. I usually move the terms so that the squared term is positive. So I'm going to say x squared. I need to put it in standard form. So ax squared plus bx plus c. Let's subtract 2x from both sides. That leaves me 0 on this side. That's what I wanted. And then minus 15 equals 0. Yay. So now we do what? What we learned in Algebra 1. Hey, what multiplies to give AC, in this case just negative 15, and adds to give negative 5. Multiplies to give negative 15, adds to give, adds to give negative 2, right? But multiplies to give negative 15 and adds to give negative 2. And hopefully it doesn't take too long before you realize, hey, negative 5 times 3 is negative 15, and negative 5 plus 3 is negative 2. Shazam! We're done. Because I don't have a leading coefficient of anything greater than 1 to worry about. I don't have to do factor by grouping. I don't really even have to do the box method. When the leading coefficient is 1, these are my factors. So x minus 5 times x plus 3 equals 0. Just double check. X squared plus 3 minus 5. Yeah, that's negative 2 minus 5. Okay, so we factored it correctly. The last step in factoring is to solve. So if x minus, you take each of these factors, remember, set them equal to 0. If x, we're using the 0 product property. If x minus 5 equals 0, then x equals positive 5. If x plus 3 equals 0, then x equals negative 3. All right, so we have two answers. But one of the things we need to do, just like when we did square root functions, just like when we did rational functions, we have to check, because sometimes in our squaring and rooting, we get something called an extraneous answer. Do you remember that? When we would get something called an extraneous answer, we did the math right. We got the answers down here at the bottom, but when we plugged it back in for some reason, it just didn't work out. Well, we got to check for that. And one of the things that we need to think about, we need to remember from our parent function the domain of logs. If you remember, the graph on parent function of a log looks something like this, doesn't it? And look over here. What's happening in negative x land? Nothing, right? I've got negative y's and positive y's, but I don't have any negative x's. In fact, when we did our parent functions, we learned, hopefully, that the domain of a log is strictly greater than 0. In fact, if you have your calculator, you can try to take the log of a negative number. You have a log button on your calculator. We haven't used it yet because your calculator is just in base 10 or in base E, which we'll talk about later. But we can even just try in base 10. So let's just say, let's try to take the log of negative 6. And I'll say log negative 6. The log button is right next to the 7. Right here, you see it says log. Okay, so there we go. Log of negative 6. And now I'm going to hit enter. And look what it wrote. Can't do it. Can't do it. You can't take the log of a negative number. Not in the real number system. So that's something to think about it when I go in and check my work. So let's check our answers. And we'll check by taking these values and plugging them back in. All right. So the log of base 3, 5 squared minus 15. 5 squared minus 5 squared is 25. 25 minus 15 is 10 equals the log base 3 of 2 times 5. 2 times 5 is 10. So what do I have? The log base 3 of 10 equals the log base 3 of 10. Does that work? Heck yeah. Okay, so that checks. That means what? 5 is an answer. Now we got to come check this one. Now, I'll be honest with you, I'm suspicious about this one because it's negative, but that doesn't mean necessarily that the argument ends up being negative. For example, like up here it says 2x. What if it said negative 2x? Well, a negative number would work. So be careful. You always have to test. You can't say, oh, well, it's negative, so it doesn't work. No, it could work. Let's see. All right. Log base 3 of negative 3 squared, all right, that's 9, minus 15. 9 minus 15, that's negative 6. Let's see. Log base 3 of 2 times negative 3. That's negative 6. And while it's true that log of negative 6 equals log of negative 6, yes, except for guess what? Negative 6 is out of the domain. You can't take the log of negative 6. Look what's happening over here at negative 6. Nada, zilch, nothing. Okay? So there's nobody over there for you to take the log of. So no, 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 nope, nope, nope. So this, remember, we would say what? Remember our word? Extraneous. So what's our answer right here? X equals 5. Yay! That's the answer. Okay? X equals 5. So I think probably we need to do a second example. And this one will go a little faster. You've got these notes in front of you. They are in your book, but let's go in and do a second example of solving, all right? So on the next page, we're going to do another one where it just says solve. And we're going to say, so this would be example 2b. And it's going to say log base 3 of 3x plus 8 equals log base 3 of x squared plus x. All right. I have logs on both sides. I have an equal sign. I have both of them are in base 3. So then you have to ask yourself, how am I going to solve this? Am I going to use the definition and rewrite it as an exponential? Or am I going to use the property of equality for logs, which says log base b to the x equals log base b to the y, so x equals y. And that's what I have. So you have to recognize that pattern. So because these are one log equals another log, and I don't have like extra stuff over here, it doesn't say plus 3 times the log of 48. Nope, nope. It's just log base b of this equals log base b of that. That's it. So now I can use the property of equality, which says set the arguments equal to each other. So 3x plus 8 equals x squared plus x. The logs are gone. And it looks like linear on this side and boom, quadratic over there. So it looks to be like another quadratic equation. So we have a possibility of 2 solutions, or maybe 1 solution, or maybe no solutions. So keep that in mind. We could have 2, 1, or none, right? Okay. So again, you can move the 3x plus 8 over here. You can move the x squared and x over here. Just remember, of course, when they move, the signs change. I usually like to keep the x squared positive. That's just me. So I'm going to subtract 3x from both sides, and I'm going to subtract 8 from both sides. And when I do, we get x squared. 1x minus 3x is negative 2x. And then I subtract 8. And there we are. And then, oh goody, this is a quadratic that's not hard to factor. we're looking for things that multiply to give -8 and add to give -2. Again, multiply to give -8, add to give -2. I don't have to worry about this leading coefficient up here since he's just 1. It makes it much simpler. And -4 times 2 is -8, and -4 plus 2 is -2. So we found the factors. 0 equals x minus 4 times x plus 2. And it doesn't ever hurt to multiply back and check, make sure we did it right. X squared plus 2x minus 4x, yep. -4 times 2, yep, we did it right. Okay, so we factored it, but now we need to solve, all right? And what do we do when we have factors that are set equal to 0? We're going to use that zero product property. It says the only way this is true is if one or both of them equal 0. So we're going to take the first factor and set it equal to 0. And we'll take the second factor and set it equal to 0. If x minus 4 equals 0, we add 4 to both sides, and we get x equals 4. If x plus 2 equals 0, we subtract 2 from both sides, and x equals -2. There we go. And we're done, except for we got to check. So let's do that. Let's plug it back in. If I'm up here and I plug it back in the argument, 3 times 4 is 12, plus 8 is 20. So I get log base 3 of 20 on this side. And then if I plug it in here, x squared is 4 squared is 16, plus x is 20. Log base 3 of 20. Is that true? Yes. Is there any problem with taking the log of 20? Nope. So guess what? 4 works. I should write down what we're doing here. We're checking. Okay. Now, just because 4 works doesn't mean that -2 doesn't. Because again, how many solutions does a quadratic have? It could have 2, because all quadratics have 2 roots, but it could have 2 different numbers. It could have 1 double root, right? Or it could be what? Completely above or below the x-axis and have no solutions, no real solutions. So you have to check. You can't just assume, oh, well, this one's negative, so it's not going to work because we had a negative a while ago and it didn't work. Well, you're right, but this one might. So we have to check it, okay? So let's plug in -2. 3 times -2 is -6, and -6 plus 8 is 2, okay? It's 2. So what do we have? On this side, we've got log base 3 of 2. Okay, let's see what we have on this side. We're going to take -2 and square it. -2 squared is 4. 4 plus -2 is, guess what? 2. Do those equal each other? They do. Can you take the log of 2? Yep, it's not out of the domain. So guess what? This one works as well. So they both work. The first one works and the second works. And that is how you use the property of equality for logarithms to solve log equations. And next week, we're going to be looking at some other kinds of properties of logs and some cool things that they can do by expansion and condensing. Kind of use something like exponent rules. We'll look at common logs, which are the ones that are used the most. Common. They're in base 10. So until then, keep working hard. Keep doing what you're supposed to do. Logarithms, we're going to figure it out, and I think that you're going to do well, but we're not going to take it too fast, okay? So do your best, and we'll have another class Zoom. If you have questions on it, you can ask then. So love ya. Bye-bye.